So in this video, I'm going to review really quickly the difference between square root and perfect square, and then we're going to go through pages 14 and 15 in your packets. So this is a video for pages 14 and 15. Now, real quick, the square root of 100 is 10. When you see that, the square root of 100, we're basically talking about the square root of 100. And so the square root is 10. Now that means that 100 is the perfect square, okay? 4 is both a square root and a perfect square, and here's why. If we take the square root of 16, the answer is 4. So 4 is a square root of 16. It's also a perfect square because if you do 2 times 2, you will get 4. So 4 happens to be both of these types of numbers, all right? I could also come up with a few other examples. So if I take the square root of 256, the square root of 256 is 16. So 16 is also a square root, and 16 is a perfect square because if you do 4 times itself, you'll get the 16. So there are a few examples of numbers that are considered both. But up here, I wanted to go through the fact that the 100 is the perfect square, and the square root of the 100 is the 10. So now, we're going to go to page 4. And on page 4 at the top, or not 4, we're talking about, page 14. At the top of page 14, there are 6 different numbers, and you've just got to go through and sort them and decide which ones are perfect squares or not. So the chart in my classroom, I think most of you have 1 squared through 15 squared memorized, which means you're easily going to see that the square root of this would be 14, so it's a perfect square. You know that the square root of 225 is 15, so it's a perfect square. You probably catch that 46 is not perfect. Now, I am a little bit worried that you would not catch that this is a perfect square. I do want to point out that if you take 361 and take the square root of it, it is 19. So 19 times 19 is 361. So yes, this one is a perfect square. And the square root of 121 is 11. So those are the 4 perfect squares, which means 46 and 266 would not be perfect squares. If we took the square root of these, they would be considered irrational, and you might remember that from earlier in the school year as well. All right, now this question in here, this one's actually just sneaking in. The next page continues on with perfect squares and square roots. So I'm going to walk you guys through number 18 real quick. It has Emily wrote the numbers below in her notebook, and we want to determine whether or not each number is greater than the value of the 575, or is it going to be less than that value? So for the first one, it just reviews scientific notation. The decimal moves back twice, and that number would be a 0.057. That one is smaller than a 0.575, so that's over here in this list. All right, now for the next one, we're just taking a percent and making it a decimal. So if I take this decimal and move it back twice, I actually get the same decimal as the first one, which is why you see this also over here for less than. Now the third one, anything to the 0 power is just 1, so we're actually multiplying 5.75 times 1. It's just itself, the decimal doesn't move. So 5.75 is bigger than 0.575. For 23 out of 400, when you divide that in the calculator, that one you probably would need a calculator for to divide 23 by 400, and it's going to be that. Now another thing I want to point out, y'all, if you were just trying to do this without a calculator, think about it this way. 200 out of 400 would be a half. We're looking at something that's more than a half. So if this is nowhere near 200 out of 400, this is nowhere near a half, 0.5 would be a half. This is clearly much less than that decimal. And then here, 575%, when you move the decimal back twice, you get 5.75, and 5 wholes would be much larger than something that's not even a full whole. So we had this answer right here, and this answer right here were the 2 that we put over here for greater than. Now I want to remind you guys that at any point, if you just want to stop the video and try these questions on your own and then just hit play to see how you're doing, that's totally fine. Now for number 1 over here, we're now on page 15, still a non-calculator section. So we're still trying to do all this without the calculator, which means we want to know these perfect squares by heart. The square root of 16, we're just showing here that when you do 4 times 4, that is the area, and in here you'd get 16 square units. So if there are 16 square units, to find the length of one of the sides, you just take the square root of 16, and one of the side lengths would just be 4 units. For number 2, again, another area application of a perfect square. If this was a 7 by 7, we'd get the 49 square units. So the square root of 49 is the 7. All right, for number 3, the square root of 144 is 12, because 12 times 12 is 144. And the square root of 900 is 30, because 30 times 30 is 900. For number 5, it asks which of the following is the square root of something that is considered a perfect square. And here, C is the only one where 121 is a perfect square, and we'd get 11. If you try to take the square root of 110, 114, or 125, you're going to get one of those irrational decimals that goes on forever and ever and ever. And now for number 6, which of the following is not the square root of a perfect square? So the square root of 196 is 14. The square root of 289 is 17. The square root of 361 is 19. And if you need a calculator to see this, 420 is actually not a perfect square. This technically keeps going. It just stops because it's run out of room because we're in the calculator. Like it runs out of room right there. So I do want to remind you guys that you have like everything up through 15 squared memorized, I would say. You know that that's a 225. I would definitely make sure before the SOLs, if you haven't already, that you know what 16 squared is, 17 squared, 18 squared, 19 squared, and last but not least, that 20 squared would be a 400. You can use a calculator to get those, and just make sure you get those numbers memorized before the SOL. And that concludes the video on perfect squares and square roots for pages 14 and 15. Thank you.